This lesson is titled Parallel and Perpendicular Lines. What are parallel lines? Parallel lines, as you can see, are just lines that are in the same plane, so they're coplanar, that don't intersect. So these lines that are appearing on the screen are parallel lines. They're in the same plane and they don't intersect. Can you predict whether two lines will intersect? Let's look at some of these equations. Y equals 3x, y equals 3x plus 3, and y equals 3x minus 4. How are the equations alike? Well, you should say that they all have the same slope of 3. How are they different? You should say that they all have different y-intercepts. The bottom one has an intercept at -4, the middle one has an intercept at 3, and the top one has an intercept at 0. If we graph them on the same set of axes, we will see some interesting things. To graph y equals 3x, let's pick a couple of points for x. When x is 0, y is 0. When x is 1, y is 3. Let's go ahead and pull up some graph paper here. Plot 0, 0, and 1, 3, and draw the line. So there's our first line, y equals 3x. Let's go ahead and graph the next line, y equals 3x plus 3. When x is 0, y is 3. When y is 0, x would have to be -1. So let's plot those points. 0, 3, and -1, 0, and draw the line. So there's our red line, y equals 3x plus 3. And finally the last one. When x is 0, y is -4. When y is, let's see, it looks like I've got when x is 1, y is 1. 1 doesn't make sense. Yeah, it is. Y is -1. X is -1. We've got x is 1, y is -1. So when x is -1, y is 1. When x is 0, y is -4. There's our green line. So what do we notice about these lines? They're coplanar and they're in the same plane and they don't intersect. We have to fix the colors on these so we can see those points better. X is 1, y is -1. How are the graphs? How are they alike? Well, they all have the same slope. They have the same steepness in the graph. How are they different? They all have different y-intercepts. So parallel lines have to have the same slope but different y-intercepts. That way when we graph them, they won't be on top of each other. They won't intersect each other. They'll be parallel. Write an equation of another line with the same slope as the line y equals 3x. Predict whether that line will intersect the graph in step 1. Well, if we pick any equation, y equals 3x plus or minus any other number than 0, 3, or -4, we'll have something that's parallel. For each linear system, predict whether the lines will intersect if you graph the equations on the same set of axes. How about these? Will they intersect? Well, here I have a slope of -2 and here I have a slope of -4. If they have different slopes, they will intersect. So yes. And notice if we draw the graphs, we'll see the actual intersection point. Here I have a slope of -2. Here I have a slope of 1. Different slopes. They're definitely going to intersect. If we graph them, we'll see the intersection point. So if they have different slopes, they have to intersect. If they have the same slope but different y-intercepts, they're going to be parallel. Here I have a slope of 1. Here I have a slope of 1. Opposite of A over B is 1. So they will not intersect. They will actually be parallel. Slopes of parallel and perpendicular lines. How are the slopes of perpendicular lines related? Find the slope of each line. Well, we can find the slope by using the formula slope is equal to the second y minus the first y over the second x minus the first x. So we can use the point 0, 0 for line A here. We can also use a point that we can find easily here. Somewhere along here will we find there. That looks like a good one. We could use that one because it's going right through the crosshairs of the graph, or possibly this one is going right through the crosshairs of the graph. We're going to choose to use the one up higher. That is the point over 3 and up 4, so that's the point 3, 4. So if we use this formula to calculate the slope, we would have 4 minus 0 over 3 minus 0, or 4/3. Let's do the same thing for line B. we've got the point here at 2, 0, and we've also got a point here at negative 1, 1. Let's use those points to calculate a slope. 1 minus 0 over negative 1 minus 2 is negative 1/3. And finally, line C. We've got a point here at 1, 0, and another point here at 0, 2. If we go ahead and calculate the slope, we're going to get negative 2. So we found the slope of each line. How are the slopes of perpendicular lines related? Well, let's see if we can figure that out. We've got this line A still here. That had a slope of 4/3. Remember, we calculated back here that it had a slope of 4/3. Let's try to draw a perpendicular line. Let's try to use the computer to do that for us. So we're going to take these two lines, that one that's on the x-axis and one that's on the y-axis. Those are perpendicular. We know those are perpendicular by definition. If we keep these two lines fixed and we rotate them so that one of the lines is exactly on our line A, there should still be perpendicular. We know the slope of this line is 4/3. We've already calculated it. Let's find the slope of the other line. Here's just the calculation for line A again. The slope of the other line, we've got the point down here 4, negative 3 over 4 down 3. We've also got 0, 0, and we could use this point back here. We used 0, 0. So second y minus first y over second x minus first x. Notice we have a slope of negative 3/4. So we see the same digits here, but in a different order. In fact, if we line these up and take a look at them and compare one slope 4/3 to the other slope negative 3/4, we see that these are what we call opposite reciprocals. Opposite means one's positive, one's negative, and reciprocals means that they're just flipped over. 4/3 is the reciprocal of 3/4, and vice versa. 3/4 is the reciprocal of 4/3. So, what is the slope of a line perpendicular to the line y equals 5x minus 4? Well, this line has a slope of 5, so if we're going to take the opposite reciprocal, we'd need negative, because this is positive, and then flip the 5 over, we get 1/5. So the slope of the perpendicular line would be negative 1/5. How about this line? Negative 3/4 is their slope. Well, the slope of the perpendicular line would have to be positive, because this one's already negative, and we flip over the 3/4, we get 4/3. Slope of a horizontal line. So a horizontal line is going straight across. Well, it has a steepness of 0. It's not steep at all. So the slope is 0. A vertical line straight up and down. It's so steep we can't measure it. So that slope is actually undefined. We cannot measure that slope. These are the book definitions of parallel and perpendicular lines. It says when the slope of a line is m, the slope of a parallel line is m. That's a fancy way for saying that they're the same. When the slope of a line is m, where m is not 0, the slope of a perpendicular line is negative 1 over m. That's a fancy way of saying they're opposite reciprocals. So let's put that in plain English. Parallel lines have equal slopes, and the slopes of perpendicular lines are opposite reciprocals. I would try to memorize this kind of language as opposed to the general book kind of language that we would see. Slopes of perpendicular lines, remember, they use the same two numbers, but we have to reciprocate them and take the opposite. So they're opposite reciprocals. That'll give us perpendicular lines if we have two slopes like that. Write an equation of the line P that goes through the point negative 6, negative 1, and is perpendicular to the line y equals negative 2x. Well, the first thing we need to, 2x minus 3. The first thing we need to do is find the slope that we need. So if we're going to be at negative 2x here, we're going to have to take the opposite reciprocal of that, which would put us at 1/2. And then we're going to use the point that they gave us, negative 6, negative 1. So we're going to use y equals mx plus b, plug in the 1/2, so y equals 1/2 x plus b. Now we're going to put in negative 6 for the x and negative 1 for the y, and solve for b. Half of negative 6 is negative 3. Add that 3 to both sides, and we find out that b is 2. Now take this answer for B and put it all the way back up in here, and we find the equation of our line to be y equals 1/2 x plus 2. We can't see that down here. For some reason the bottom of my screen is black, but it's y equals 1/2 x plus 2 would be our final answer. There it is. That's our learning target for this lesson. I'll see you in class.